Hello, and thank you so much for your interest in Bubbln, a ChatGPT powered network automation tool that makes use of APIs to prompt ChatGPT to generate Ansible codes, which are then used to automate a network. Bubbln aims to simplify how networks are being provisioned, thereby increasing a network engineer's productivity and reducing deployment cost. This is my master's degree project at Birmingham City University, and my name is Olasupo Okunaiya. In this video, we want to demonstrate the use of Bubbln to automate a much more complicated network, unlike the two router networks that we have been automating in the past. This is a 4 router network that has multiple routing protocols on the routers as depicted on this topology, and we can immediately see a difference in the topology here. This is because we built this using the EIGRP, and a sharp contrast is the fact that only one router is directly connected to the controller. All other routers have their connection through router 1, and that is also reflected in the pre-configuration that is done on each of the router. So we will just quickly go into the routers to see what we currently have configured on them. So for router 1, we can see that two interfaces are configured: G0 for connectivity to the controller, and G01 for connection for other routers to have connectivity to the controller through router 1. No other interface has been configured. Also, when we check the routing protocol, we can see that no routing protocol has been configured on router 1. We have a similar case with router 2 as well. Router 2 show IP interface, show IP interface brief. We have just two interfaces configured as well. That's G00 for connectivity to the controller through router 1, and G02 for connection through router 2 for other routers. So also we do not have any routing protocol currently configured on router 2, as we can see. For router 3, it's almost a similar scenario as well, where we have two interfaces, G0 connected to R2 and G01 connected to R4. We also do not have any routing protocol currently configured on router 3. Finally, for router 4, we have just one interface currently configured, and that's for connection to R3 so that it can gain connectivity to the controller. So also we do not have any routing protocol currently configured on R4. So with that, we will be provisioning these parameters, these loopback interfaces, and these protocols as seen on the topology using Bubbln. So we then launch Bubbln on the right here. Now all these parameters have been preloaded to save us some time, so we're just going to load it straight away. What we have on the right here suits exactly what we have on this topology. So we will click on yes, so that the Bubbln then can use the parameter inputs here to generate the prompt and then send it down to ChatGPT, so that ChatGPT can then generate the corresponding Ansible codes for us to execute. So the first Ansible code for router 1 has been generated, and the overall structure of this Ansible code playbook follows the YAML pattern, the YAML format, and iOS config module is also used to as to execute the different commands, and We can also see that the IP addresses for each of the loopback interfaces, meets our requirement. Also, OSPF routing protocol 1 was configured, and the networks that we advertise also meet our requirement. So we will just come back here, go into router 1, so that router 1's console, so that we can see how Bubbln will be executing the commands on the router. So we press Y and then enter. So first, Bubbln tries to log into router 1, which will happen now. Okay, so that has happened. Next, it configures loopback 0, and then loopback 1 also configured here. Then finally, it configures the routing protocol and exits the router. So after exiting the router, it goes on, create the prompt for router 2, sends it down to ChatGPT for generation of the corresponding Ansible playbook for router 2, and that is exactly what is going on now. And we should get a response from ChatGPT any moment from now. Great. So ChatGPT has responded with a playbook for router 2, and we'll just examine it to be sure it's okay. So the overall structure of the playbook again is fine, follows the YAML format. The iOS config module was used to implement the commands. For loopback 0, we have the IP addresses correctly configured. Loopback 1, same thing. Now we have OSPF, configured here with these two networks advertised, and EIGRP configured here correctly with these two networks advertised. Then OSPF is now redistributed into EIGRP here, and EIGRP redistributed into OSPF here. So this looks good. We go into the console for R2 to view what is going on real time. We press Y on Bubbln and then watch the execution of the code on R2. So first, Bubbln logs into R2, which it has done successfully here. Then configures protocol loopback 0. Next, configures loopback 1. We can see at this point that adjacency has been established between R1 and R2 in OSPF. It configures the other commands here, that's redistribution of the different protocols, and then logs out of R2, and then generates the prompt for sending down to ChatGPT at this point, and then we just need to wait for ChatGPT to give us feedback on the playbook for router 3. So ChatGPT has responded with the playbook for router 3. Once again, the overall format looks good, and loopback 0 has been configured with the writing, router 1, loopback 1 as well, EIGRP well configured here, OSPF also well configured, and EIGRP OSPF redistributed over EIGRP at this point. OSPF configured with the required networks to be advertised, and over here we have EIGRP being redistributed over OSPF. So everything looks fine there. Again, we come into R3 here and then execute the command and watch it being executed here. So first, Bubbln logs in successfully. Next, it tries to configure the loopback 0 interface, which we can see here. State has changed to up. Next, loopback 1 is being configured. Neighbor adjacency has been established on EIGRP between R3 and R2 here, as we can see. So some other configurations done, and Bubbln exits R3. So next, the prompt for R4 is being composed and then sent down to ChatGPT for generation of the Ansible playbook. This came back quite fast, and this is the feedback. The overall playbook format once again looks good, iOS config module used to implement the command lines, LUBAC 0 configured, LUBAC 1 configured, and OSPF configured here with router 10. So we come here into R10 to watch the show. Press Y here and then watch the execution of the playbook on R4. So first, Bubbln logs into R4, configures LUBAC 0, configures LUBAC 1, and then next configures OSPF. Adjacency has been established between R3 and R4. So now we will verify the configuration on the routers by doing a route, by checking the routing table. Okay, so the expectation is that right now we are in the console for R4. The expectation is that all networks, on R3, R2, R1 will be discoverable by R4. So we will just check now one after the other. Okay, so let's expand this a little bit. Okay, so here we are. All right, so here we have 172.168, which is attached to R1. Okay, and then we have 192.168.2.0, which is the network between R1 and R2. Next is 192.168.4.0, which is between R2 and R3 here. All right, then next is 192.168. Okay, sorry, not that. Next is 192.168.10.20.30.40.50 and .60 here. Okay, so that's 10, 20, the two LUBAC interfaces attached to router 1. 30 and 40, the interfaces, the networks attached to router 2, then 50 and 60, the networks attached to router 3. So all networks on this topology are reachable by R4. So again, we go into R1. The expectation is that all networks from R2 to R3 to R4 should be reachable by R1. So show IP route again. All right, so we can also see here the outcome. All right, so first is 192.168.4.0, which is the network between R2 and R3. Next we have 192.168.6.0, which is the network between R3 and R4. Next we have 192.168.10.0 here. Then we have 192.168.30 here. We are currently in R1. Okay, so in R1, so the expectation is we should see 30, 40, 50, 60, 70 and 80, which is this 30, this is 30, this is 40, this is 50, this is 60, this is 70, and then this is 80. So this shows that this network has been successfully automated, has been successfully provisioned. The network is live and carrying traffic. Okay, and this has taken us a total of 397 seconds. 397 seconds, which is about 6 minutes and some 30 something seconds to bring up this entire network. Thank you so much for your time. We really appreciate. See you next time. Bye bye.